Okay, so I think we're ready to go. Good morning, everyone. Welcome to the first panel. As was introduced, the theme of this panel is to... Can we get you guys in the back there? The theme of the first panel is really to expand and diversify our user bases to optimize the benefit for Canada. And so what CFI has organized this morning is to have three speakers representing three very different MSIs. And so that's really, I think, the important point of this panel, to hear from three very, very different MSI, what they're doing, what their barriers are, what their strategies are to overcome barriers to expand their user base. And so we have Monique Albert. She's the CEO of the Center for Biodiversity Genomics. We have now Jida Kohli, he's the COO of Snow Lab, and Jody Kohli unfortunately couldn't come, so thank you very much for stepping in last minute. And we have Alexandra Forrest, who is the Director and CEO of the Amundsen Science Lab. And so what we have planned for this morning is for each of the three panelists to give a short presentation about their MSI, and then for them to identify barriers that they have to expand their user base and what they're doing to overcome these barriers. And then we would really like to invite all of you, so all MSIs, to then contribute to a discussion. What barriers do you have? And what strategies or what plans do you have to overcome those barriers? And that really should be a discussion amongst all of us. So we'll have two microphones that are going around. And I really invite you, for the benefit for all MSIs, to contribute to that discussion. So we'll start with the first presentation. Monique, the floor is all yours.
Thank you. Well, thank you for the invitation to participate. I really appreciate the opportunity to share with you a little bit about the CBG, who our user base is, and what strategies we employ to grow that user base. Is it going? It's not advancing. There we go. So the Center for Biodiversity Genomics is a separate university research center located at the University of Guelph. We occupy 3 full buildings there, a little bit of space offsite as well at a research park. And we envision a world where we read the biosphere with DNA. And this is really setting the stage for a future global monitoring system. Slow to advance. So this is in response to the rapid biodiversity decline that is observed all over the planet. A 60% decline in vertebrate species since 1970, a 75% decrease in insect biomass since 1980. For those of you who have yet to be introduced to DNA barcoding, this is an innovation that was developed at Dr. Hebert's lab roughly 20 years ago. And it's achieved by sequencing a small region of the mitochondrion, the CO1 gene. Within that CO1 gene, it's highly conserved within a species and is different between species. And this enables a rapid, cost-effective sequencing-based method for species identification. We can use this technology to do species discovery across large regions and ecozone validation, as we have done here in Canada, and also illuminate species interactions. Services at the CBG are really based around biodiversity genomics. This encompasses a very large biorepository of roughly 10 million unique specimens that is matched with digital images and with DNA isolates. We offer sequencing services at a capacity of 3 million DNA barcodes per year and metabarcoding. And all of that data gets ported into our informatics systems, the Barcode of Life data systems, or BOLD and MBRAVE. We presently house more than 14 million DNA barcode records, representing more than 1 million unique species. We've had very strong usership in recent years. 3 million new specimens and DNA extracts have been added to our system. This comes from countries all over the world, including around Canada. 2.1 million specimens were sequenced in that period, and this year we're on target to hit 3 million. Individuals from 1.9 million unique IP addresses have visited our data systems and analyzed more than 94 million records just in that 1 year period. In terms of the demographics of our user base, it is fairly broad. It includes academic, government, public, private sector, for both the sequencing services and the informatics services. Highly concentrated within Canada, but also all around the world. So you asked us what user diversity means to us. We look at this in a few dimensions. One, we look at what sector those users are coming from. Is it agri-food? Is it conservation? Academic universities and researchers, and so on. We consider what location they're from. We also work with citizens through our schools programs, and we work with communities. We also consider the developing nation status, which is of particular relevance, considering that much of the world's biodiversity is concentrated within developing regions. In addition to demographics, we consider our user diversity with respect to how we work together. So are we collaborative? Is this a collaborative relationship? Is there a fee-for-service exchange? What kinds of resources are they accessing from the CBG? Are they depositing information and materials to help grow the asset at the CBG? Or are they extracting information to derive some meaning and generate impact? So I'm sure you are also considering these influencing factors and developing your strategy for growing the user base. Some common categories that I think we're all thinking about is, are we offering the right products and services to meet the needs of the user community? Is the quality sufficient for their downstream purposes? Is it robust, fit for purpose? Is it easy to access those services, or is there some kind of friction along the way that is impeding their access? Is pricing prohibitive? Is the user community fully aware of what we can do and what we can offer? And are we building strong relationships to enable large-scale projects and programs? So here are a few of the small ways that the CBG addresses each of those influencing factors. I'll dive into a few of those that are in green in more detail. So the CBG solicits user and expert feedback through a number of means. We collate that feedback and use it to inform how we might address any gaps in our services to make it more relevant to that user group. And we're developing technologies and advancing capabilities in the direction that the user community is going. We've considered every point along our process where we might engage with those users and have made it as streamlined and simple as possible. We package up kits, send those out to users so that they can collect their samples and send them back to us in a standardized way. We have checklist training programs, user manuals. Our informatics systems are intuitive and easy to use. We've worked really hard to raise capacity. The demand is incredibly strong for these services. Just in the past 3 years, we've tripled our capacity, going from 3 million sequences and specimens per year to 3 million. And we're also increasing our data systems capability by 10-fold within the next year. We've been quite aggressive in reducing costs. So this is in respect to our digital imaging, extraction, and sequencing costs. And what that enables us to do is to work with more users, but also larger, more complex projects. Marketing and outreach is multi-layered and multifaceted, and we use creative opportunities to amplify the message. One that I would like to point out is the image in the middle of the CN Tower. That pattern is actually the barcode for the Canadian beaver, and we put that up in coordination with one of the major events that the CBG was hosting. The success of the CBG is really dependent on the strength of the relationships that we have with the user community. And with this at heart, the CBG launched the International Barcode of Life Consortium in 2010 with funds from Genome Canada. The CBG hosts the Secretariat, organizes all of the conferences so that we can really bring that community together. The CBG leads global research programs and invites participants from that consortium and around the world to participate. So each of those countries are now raising their own dollars and creating their own programs to participate in that greater initiative. The samples and the data all come back to Canada to grow these resources. A lot of that money comes back to Canada to accomplish the analytics. So in that respect, it really secures the CBG's position as the global authority in biodiversity genomics. And we're taking that a little bit further and contemplating what that might look like in the future. Technology has become quite portable and more affordable, and we're now in a position where we can take everything that the CBG has developed over the last 20 years, package it up and make it available to other countries to launch their own smaller nodes or core facilities using the technologies, processes, and skills and tools that we've developed here at the CBG. This is helpful for biodiversity genomics, DNA barcoding in situ within those countries, especially for countries that have difficulty exporting samples to the CBG. And this again positions the CBG and Canada as the leading authority in this space. So you had asked about what challenges we experience or anticipate in broadening that user base. And a lot of it really comes down to what the final mission is. And the final mission is to provide tools to the world to protect biodiversity, to inform what those policies and strategies might be. We've made a commitment to generate data for half the world's ecoregions. There's 867 of those. This means we need relationships with people in all of those regions to go out into the field, collect those samples, and send them back to us. We are seeking synergy with users who are in alignment with that greater mission. We have a lot of users, 1.9 million users a year coming to our databases, so we're not really seeking to have more users. We're seeking rather to shift that towards high-impact sectors, those sectors that are going to generate the most impact and the best tools for preserving biodiversity. Governments are wanting data to inform their strategies. At the UN Biodiversity Conference, the COP15 that was held in Montreal in November last year, there was a commitment made to preserve 30% of the world's landmass by 2030 for preserving biodiversity. But what landmass? What's the best regions to protect? We need data to inform those decisions. So we're anticipating that these are user groups that will want and need this kind of information. So with that at heart, we're mitigating that with developing natural capital accounting tools, sequencing-based biodiversity indicators, and digesting information in a way that will be usable with these user groups. So it really comes down to relationships for us. That's the biggest thing. Make our processes as useful, as purposeful to that community, share our knowledge as much as possible, but also build these relationships so we can accomplish this greater aim. And so with that, I would like to thank you and thank our funders for the opportunity to do this work.
I see myself. That's great. Comment on switch la présentation? Oh yeah, okay, we get it. Thank you. Sorry. All right, good morning everyone. I'm Alex Forrest, the Executive Director of Amundsen Science. I just want to rectify something that Volker said earlier. I'm not the CEO of Amundsen Science, but the COO. And the CEO is Marcel Babin, professor at Laval University, who could not join us today, but he's with us, all the time. So I'm really happy to be here today to present you an overview of aspects regarding our user base with the Amundsen. So I'll present you that in the next few slides. So the Amundsen is the research vessel among the MSIF facilities. So it has been retrofitted for science in 2003. So supported many tens of programs over the years. Many scientists, more than 3,000 of course, boarded the vessel in the last 20 years. And it's a state-of-the-art research vessel equipped with all the equipment that is needed to conduct oceanographic research and also beyond oceanographic research. We had some Inuit health studies in the past, trying to do more of this in the future, but mainly all those instruments supporting state-of-the-art oceanographic research in the Arctic. What is important to understand is the user base of the Amundsen, which is about 1,100 per year. So only 1 out of 6 of those users will actually board the ship. So we have what we call those primary onboard users, and also what we call the second level users. So those people are scientists, students, and so on that do not board the vessel, but we do use data from the ship, of course, to do their thesis and so on. So without the primary users, there won't be any, of course, second level users. Some statistics about those two classes of users. So this is for the last 3 years. So it has been dominated, of course, by Canadians a bit because of COVID. So we had a bit less of international representativity on the ship. But if you look at the second level users, more than a third are real scientists working outside of Canada using data from the Amundsen to conduct their research. There's a very strong share of university participation, and also of HQP, especially on the ship. And we have okay. It seems that I do not control exactly the slides here. Okay, sorry for that. I think someone is trying to keep it with my tone, so we'll see. So about a third of the primary users are students, PhD, master students, postdoc, and it's the same more or less for second level users as well. An interesting statistics though for primary onboard users are the fact that we have about 50% men and women, and also 50% below 30 years. So we have a very young cohort on board the vessel, so this is really important to understand. Next slide, please. So we really care about the onboard users a lot because they are both, what they will do on the ship is both a scientific and human experience, even very often life transformative. So we develop over the years a very strong connection with our user base. Those people that board the ship that will become professors after that are students, and maybe some of them won't board the ship because they have a thesis on something else, which is more on modeling. But this kind of very, very strong cohort that we have, we develop a very strong bond. Next slide, please. So what diversity means, we have two definitions. The first one is that the program level. So you can see that about 10 years ago, we had kind of a low diversity, lower than today. So this is when ArcticNet was managing and using the ship as the main user. And okay, right. And then after that, beginning in 2017, we had the Amundsen Science, which has been implemented and created to manage the ship as a national infrastructure, and then the diversity really increased. So this is a diversity index that we created for the key performance indicators, and then you can see that over the last 6 years, we had a very high diversity, although it's kind of reaching a plateau. Yeah. Next animation. Yeah, thank you. So this is when Amundsen Science took over the management of the ship. So ArcticNet is not anymore the manager, it's mainly only a user of the ship among many other clients. But we're trying now to even more diversifying the user base. Next slides, please. So a good example of the diversification is the IMAPIVOT 2023 program that we had last summer. So this was the first primary program led by an Inuit organization with the first Inuit chief scientist on board. A very interesting program. So this is a good example of how we can diversify the user base these days. We're using high technology and so on. Okay. Before slide, yeah, thank you. Okay. So this is the IMAPIVOT Marine Plan program to study or get data to collect and make sure that the marine protected areas along the Labrador coast would be supported in terms of development. Next slide. So diversity also is also at the individual level. So this is something really important to understand. People that comes on the ship, scientists, young cohort, you can see all those smiling faces. They come from different horizons, from abroad. We have Inuit trainees, we have 50% women and men, a lot of young people, and all together they are working to collect those data for their thesis and so on. And then after that, we're actually supporting even more users, like 5 out of 6 I was just mentioning earlier. And because of this young cohort and the fact that it's so diverse, over the last few years, we really committed a strong commitment to EDI practices. Next slide, please. So we developed, for example, an EDI committee, an EDI action plan, and also we had very strong practices in terms of onboard participation with safe contact persons on board, and the facilitation of Inuit participation, as you could see in the previous slides. Next one. So strategy for diversifying and expanding the user base. So this is a question we've been asked to respond. So it's not that simple. It's not that complicated, but it's quite demanding. And the answer is simply reaching out, and reaching out again. So the way we do this with the Amundsen is with multiple means. So we do in-person and virtual visits to universities, departments, and communities. So we go there in person as much as we can. We reconnect with the user base directly in the departments and so on. What we organize also are planning workshops. We participate to relevant conferences. We organize also other kind of workshop, and also we try to increase as much as we can public awareness about the facility through newsletter, websites, and so on. So in terms of key communication and outreach activities, we are present in many places, as many of you, of course. We host an annual Amundsen Science Planning Workshop. We organize also other workshops, like the one what we did in last April on benthic research, providing also expedition summaries and report translated in Inuktitut, which is key to disseminate the information to the north. Presents to upcoming conferences, so this is just an example. Again, this is just to showcase that the only way to expand and diversify is to be present in many venues. Next slide. So something really important to understand is that actually you saw it from my previous slides. The Amundsen is really a user-centric facility. So you can continue the animation in the next seconds, yes. So they drive the science program of the ship. They develop the scientific equipment pool. Yeah, please go. you can continue. So and then they also oh yeah, thank you. All right. Okay. They are consulted through annual planning workshops and other venues, and their funding is leveraged by Amundsen Science or the MSI for the operation of the ship and new equipment. So what happens at the end of the day is, because we are so centered on the user, is that the users themselves, they become ambassadors for the facility. So this is something really important for the facility, because what is our most important success criterion is their satisfaction, because they go on a ship, they transform their lives because they go through that process, they produce scientific data that will be used by others after that. So the achievement of their scientific objectives is really at the basis of our objective. So users become ambassadors. Just to finish, challenges and mitigation approaches. So we have 3 main challenges these days. So the first one is, of course, the increasingly high ship time costs that prevent access to users. We may have no or limited access to ship time funding. The costly and complex logistics which is associated with the mobilization and access to the ship that some new users may find a bit discouraging. And the lack of awareness that many still believe that the Amundsen is always fully booked and only used by a few large programs. So we need still to change this mindset, but we're getting there. So in terms of mitigation approaches, we will do using a larger share of the MSI funding to support new projects, like the one that I showcased, like the MAPIVOT program, and some atypical new users. Increased support from our organization to support the mobilization and implementation of the research programs themselves, not in the research itself, but mainly in the planning phase and implementation. So we are really present into those planning phases, even getting some helping programs to get some funding. Because what is really unique with the Amundsen is that there's no provincial, of course, contribution. It's only the user base fees that provide the countermatch to the CFI funding. And we are continuously reaching out to national and international community, and especially to Inuit Nunangat organizations. So this is what I wanted to say this morning. Thank you so much. Université Laval was present with us this morning, our host organization, and the CFI, of course, for the continued support. And why not joining us for the next expedition next summer? Thank you.
Okay. Thank you for the opportunity to speak. I apologize that Jody Cooley couldn't be here. It's unfortunate because she's given a lot of thought and she's done a lot of work on this topic. So just to introduce SNOLAB at the beginning, SNOLAB hosts rare event searches and measurements. It's located 2 kilometers underground in an active nickel mine in Sudbury, Ontario. The nickel mine is run by the company Vale, and our facility is operated by a joint venture of 5 universities: Carleton, Alberta, Laurentian, Montreal, and Queens. And then I would also say we're on the traditional territories of the Robinson-Huron Treaty of 1850. Located on the traditional territories of the Atikameksheng Anishinaabeg peoples, First Nation, as part of the larger Anishinaabeg Nation. And our operations are funded primarily through the Province of Ontario and the Canada Foundation for Innovation. Okay, why are we underground? So there is a growing community of scientific researchers who need environments that are shielded from radiation and are clean, because dirt is radioactive to us, to achieve sensitivity for these rare event searches. So apologies for putting up a plot from a peer-reviewed journal article up here, but, well, there's a couple reasons I really like this plot. It shows that SNOLAB has the lowest muon flux. We go underground to get away from muons created in the atmosphere, which is actually created often by radiation from exploding stars. So we go underground to get away from exploding stars. And SNOLAB has the least impact from those exploding stars. And I like this plot as well because this is from our major competitor in China. You can see this is their work, showing that they're almost as good as SNOLAB. Okay, so, and also I want to note that this is about a 5,000 square meter clean room, 2 kilometers underground, which poses challenges. So the scientific strategy, and as we go through this, you'll start to see diversity in all of our strategy. This is what Jody's really been trying to do, is to drive diversity into every aspect of what we do at SNOLAB. So traditionally, the science at SNOLAB, and still, has been focused on increasing our understanding of the particles and forces that have shaped the universe. So specifically, we have a big program in studying the nature of dark matter, and a big program in studying the nature of the neutrino. We also collaborate with scientific research that requires deep underground facilities. It's not just dark matter searches and neutrino properties, but we also look for observations of neutrinos from the sun, from exploding stars, from the Earth itself, from local reactors that people are building. We can see neutrinos from the reactors at Bruce Peninsula, for example, right now. And then also there are studies on the impacts of radiation on biological systems. We're studying nematodes, human stem cells, and yeast right now. And then there's a small environmental monitoring program. We're very good at measuring radioactivity in air, dirt, and water. And so we're working with stakeholders to see if in this era where we have ambitions to grow our nuclear industry, if we can grow our environmental monitoring capabilities so that we can see any radiation in the environment well before it poses a problem for health or environment. And then we're also interested in pursuing new collaborations and opportunities in emerging areas of underground science. And here we've called out quantum technologies. Semiconductor technologies have an impact from ionizing radiation that's been studied for a long time. Quantum technologies are more sensitive to radiation, and so we have a program now to study the impacts of radiation on superconducting qubits, for example. In terms of the numbers, we have over 1,000 active academic users or collaborators. 25% of those are Canadian. We've been growing that, and it's been shrinking the percentage of Canadians, but the actual number is going up. There are 24 countries that you can see here, and you can see some of the geopolitical challenges that may exist in our collaborations as well. And this comes from over 160 institutions are our users. So what does diversity mean to SNOLAB? Well, we believe that world-class science and research excellence requires contributions from diverse perspectives. We need diverse ideas to make progress on all of the challenges that we have in research now. And people are really at the heart of SNOLAB's success. So we strive to achieve and maintain diversity in our staff, our researchers, technicians, engineers, everybody who works at SNOLAB. We take each group individually to make sure that we're not pigeonholing certain demographics into certain jobs, for example. And we are committed to a diverse research portfolio and growing the diversity of that research portfolio. So we host experiments that represent diverse and multidisciplinary research topics. We balance the size of the projects as well. We want large projects, medium-sized projects, and small projects to increase the efficiency and scientific productivity of the laboratory. And we are also, for that same reason, we also balance the stages of experiments. We want experiments in the conceptual design stage, the installation stage, the operational stage, and decommissioning stage. And so you can see all of this embedded, this diversity embedded into our new strategic plan, which is available on our website if you are interested. We have 3 pillars to that plan. The first is world-class science, drive breakthrough discoveries at the frontiers of underground science, and we believe that we need a diverse scientific program to achieve that goal. On the infrastructure, we are working to continuously improve our research infrastructure to remain state-of-the-art. We need world-class, excellent infrastructure to attract that diverse talent to achieve the diverse research that we hope to achieve. And then the skilled people. We want to foster and develop diverse talent in an inclusive environment. You can see diversity is directly in that pillar, but this is key into developing new ways for researchers to do research at SNOLAB and to improve the way these large international collaborations do business so that they are a more inclusive environment as well for everybody involved. So this slide basically repeats that. So the strategies and barriers to expanding and diversifying the SNOLAB user base is sometimes the science can be a barrier to that, so we're pursuing a diverse science portfolio. It's anchored by our world-leading dark matter and neutrino programs, but we're open to new scientific opportunities in all of the emerging areas of underground science. We host experiments at different stages of development. We provide state-of-the-art infrastructure, and we encourage and foster a welcoming collaborative environment for collaborations who use the facility. Okay, just an example. So with a great partnership with CFI over the last period, we were able to fill up SNOLAB. So that's one of the things I want you to take away from this layout of the underground space in SNOLAB. We've labeled a number of the spaces, and you can see we have experiments that are current. We have future experiments planned for some of the spaces. We have various laboratory facilities like the machine shop, life sciences laboratory, low background radiation counting laboratory. We produce ultra pure water that we distribute throughout the laboratory that's very low in radioactivity. And we also have our own utilities. We have a sewage system that we run. We have flush toilets 2 kilometers underground, which most of the miners are jealous of. And in terms of surface spaces and support, so one of our underlying threads to support our strategic plan is to become an intellectual hub that fosters collaboration and connection. Our major international competitors, this is really one of the pieces that we're missing that they have that would set them apart. So we are assigning dedicated staff to assist with domestic and international users in the navigation of the logistical aspects and the cultural aspects of their long-term stay, create a formal user support system that users can rely on, provide dedicated physical space, and you can see a picture of that here, to encourage collaboration and connection. And we're constantly trying to promote the best practices in equity, diversity, and inclusivity. As part of our life cycle process, we require codes of conduct and EDI plans from the collaborations as part of what we review throughout the life cycle of the projects. And for example, next summer, we're trying to create a welcoming environment, create this SNOLAB Summer of Science. We're going to host a series of meetings and workshops, collaboration meetings, dark matter conference, a summer school jointly with Triumph and the Perimeter Institute. And then we're going to try to have some senior scientists stay for longer periods to allow for lectures and discussions in weeks in between the events. One of our big challenges, and this is a big challenge to diversifying the user base, it's a big challenge that we've seen in the success of diversifying our user base, is that housing and particularly travel can be a big barrier for students, and so we're trying to find funding for that. It's not eligible through CFI because it's a direct cost of research, but we're trying to find other funding to help overcome that barrier for some of our collaborators. Like in Sudbury, you need a car to get around. You cannot bike to the mine site because of safety. And so people need a car to get to SNOLAB. And some of our users have never driven. So that is a barrier. Okay, another barrier is our privacy in our dries. Dries are what the miners call locker rooms. So this is a picture of our underground dry. We need to pay particular attention to equity for those who need more privacy. These were designed in the 1990s, which was a different time culturally. And we need to change both the culture and the design of these spaces to account for privacy and to account for gender diversity. We also plan to create wellness spaces underground. We have one on the surface now. So that would include both facilities for prayer, identifying which direction Mecca is, for example, and also for nursing. And then we have a challenge, of course. We are all in a strained budget situation, and the execution needs to be staged, because if we do any construction in our clean room, we have extra challenges in terms of keeping it clean. Okay, another challenge is competition. I've touched on this previously. Some of our international competitors, particularly in Europe, are making large investments, and also in China. And I think this is actually a response to some of the success that we've had in partnership with CFI over the past 10 years. Is a lot of the investments they're making are repeating some of the investments we've made in SNOLAB, although they're doing it at a very large scale. You can see 4 times their yearly running budget to update the lab infrastructure, and so that's a very large investment that we are seeing as a challenge. We have a life cycle for our projects. I won't touch on this. We do have diversity embedded in this, as I touched on briefly. My conclusion, SNOLAB is a clean underground laboratory hosting a variety of experiments. We recognize it's essential to weave diversity into the culture of the lab to retain our global leadership in science, and diversity is woven through the 3 pillars of our strategic plan of excellent science, cutting-edge infrastructure, and skilled people. And we are all excited at Snow Lab about the opportunities that we provide the scientific community, and we are well positioned to attract world-class experiments and support major discoveries in the next decade. Thank you.
Okay, so thank you very much to the 3 speakers. By the way, I missed to introduce myself earlier this morning. I'm Volker Gietz. I'm the director of VIDO here at the University of Saskatchewan. So what we wanted to do now with the remaining 15 or 20 minutes is really have a discussion. So I encourage all MSIs, and I don't know where the microphones are. There is one, and where's the other? Only one? Okay. So I encourage the other MSIs either to speak up very loud or use the microphone and really bring your perspective to how your MSI are diversifying and expanding your user base, and also if you have any specific questions for the panelists. So do we have any questions? Anybody to start this discussion? Yeah. And maybe if you can introduce yourself as well, from which MSI you are.
I'll speak loudly. Thanks for Roy. I'm the chair of the board for the Diversifying Innovation Center. I'm just wondering, maybe a question to the panel. Of course, there's an increased need for research security, and of course, there's a lot of discussion going on. I'm sort of wondering how the drive towards implementing research security measures could potentially impact the need to attract additional partners and increase your user base.
Who wants to take that? You want to start Snow Lab, maybe? Can we turn the microphones on, please, on the desk here? Number 2. Can you click it on?
All right. Okay. Sorry. Your question was research risk and how that can impact our efforts to diversify the user base. I think there could be big impacts if we do some of that in a heavy-handed way. I think at Snow Lab we do a lot of fundamental research, and I feel that there is less risk in fundamental research because the data are meant to be public. The goal is to provide those data to the public, so there's no, if somebody were to steal the data and tweet about it, we would tweet back at them and say, let us know if you see anything, and let us know if you want the software to analyze the data, generally. But I think it's very important to align with the requests for research risk. I think on the applied areas, it's very important. And so it's important to segregate those, make sure that you have the right structure to deal with risky data and not risky data, for example. I think if we can do that properly, I think that the user base will see that and will respond well. If we do it in a heavy-handed way that makes access to the data much more difficult, then there will be a negative response and it will be more difficult to diversify. The more barriers we put into place, the harder it is, especially for certain cultures. Like the Northern Ontario School of Medicine just went through a partnership with some of the local Indigenous cultures, and they found that actually the piles of paperwork was one of the barriers to increasing Indigenous research and Indigenous scholarship at that university. And so we should be cautious about the cultural impacts of what we're doing in that area, but I think it is very important that we improve in that area.
Did you want to add to that?
No, it's actually the same thing for the Amundsen. There's no real risk with the research itself. All the data are public, and we live really in a world of open data. So it's maybe in the past, 12 years ago, when we had some projects with the oil and gas industry, which are a bit, a bit sensitive, then at the time, yes, of course, we had to implement very specific rules and so on. But now it's really open, and actually the open data world within which we live is really opening the way, paving the way to even more users outside. So it's just a benefit.
Yeah, I would really echo that as well. It's mine on? Yeah, thank you. You know, the data itself, it's very difficult to misuse that. So we're not too concerned about the data, you know, being breached in any way. We're more concerned about data going down and not being available, about our systems being hacked or impacted in that way. So we want data security around that. If there are specific vulnerable species, we'll obfuscate the geolocation for that. But that's really about it. We want this data to be as openly available and usable by the community as possible.
And so maybe to build on that answer, what strategies are other MSIs using in terms of screening their users for security purposes? So here, for example, at Vito, all of our users have to go through a security screening because potentially they have access to dangerous pathogens. So maybe the question to you is, what screening are you doing on your users? And then maybe we can hear from all MSIs or from whoever would like to speak up. What strategies are you using to screen your users? Who wants to start?
Sure. Yeah, so we don't really need to screen our users. We want our users to use this data. Biodiversity collapse anywhere in the world impacts everyone everywhere in the world. So we want people to use this data to preserve biodiversity in their regions. That said, if there are specific sanctions against specific countries, we will follow the directives of our host institution.
Yeah, of course, for those people that board the vessel, there's a really strong security clearance process that they need to go through. So for typically everyone, it's not that difficult. You know, they need to do some forms and so on. But for two kind of people, it might be a bit challenging, especially when we have a researcher from abroad, Russians or Chinese, that might be a bit challenging. And also for people from the north. Inuit, sometimes they have you know, I need to say for example, an Inuit trainee who has a criminal record, you know, and then we want to come on the ship because we want to increase diversity, but finally it doesn't work because of the security clearance process. So it's good as it is bad in a sense, but there's the only way to go through that. So working with the federal government to maybe potentially find some alternative. Yeah.
And Snowlab, are you screening?
So we really, most of our projects are funded through other funding mechanisms, and we rely heavily on those for some of the screening of individuals. For example, all our Canadian collaborations are now vetted by the research offices through the software that they have. That software is quite expensive, so we don't have a license to it. But I know that other countries also vet the collaborations for this reason, and so that's where we really rely on them. We do not do a lot of active vetting ourselves.
What about other MSIs? Are you screening your users, and what are you screening them for? Anybody? CLS, for example. Is CLS here this morning? Bill, are you here? There.
I'm not CLS, but I provide a perspective on the applied knowledge.
You're going to use the microphone, it's just up there.
Oh, she's going to turn it on too.
Can you turn it on? Just.
Hello? There we go. So I'm Jenna Dancy. I'm the director of the Canadian Cancer Clinical Trials Group Operations and Statistical Center. And so because we do clinical trials testing cancer interventions on patients with cancer or those at risk, we engage health research community, patients, and most importantly, patient data collection in our research activities. So as a result, we do screen users. They have to be qualified to be able to see and treat and manage patients on clinical trials. And in addition, we screen users requesting our data sets and biospecimens for research activities. And again, that's to align with the ethical and responsible standards for the use of those data. And that may require screening in terms of understanding not only the research project that's being proposed, but also the credentials of the individual, and indeed the research project itself might have to undergo research ethics board review prior to the release of data.
Thank you. See, Bill is there.
I'm Bill Matiko, and I'm the CEO at CLS. A number of things. I think from a science security perspective, we collaborate with other synchrotrons around the world in terms of just looking at what they're doing from a science research security perspective. Certainly there's certain countries that are of interest, and some of the institutions that in our user base, they may be affiliated with certain institutions that are doing research or military development that we don't want to, as a Canadian facility, be supporting that. So we look to, there are certain countries that have lists of institutions with ranking as to whether they're a very high risk or high risk. We work with ISED and NSERC in terms of the guidance, I guess, that they provide. So it's something that's important to us. We do have users that we have not allowed to come to our facility. I think if you look at Russia, it's more of a political thing, and with the war in Ukraine, so we don't welcome Russian users to our facility. So we work very, very closely with CSIS in terms of specific individuals that are using our facility.
Good, thank you. Two more in the back.
So I'm Nigel Smith, so I'm a bit of an interloper here. I'm not an MSI, I'm at Triumph, I'm CEO at Triumph. I think one of the challenges that we're facing, Bill articulated the sort of thing that we're doing at Triumph, but one of the challenges we face is at the provincial level. And we have 21 member universities, and so we're trying to build a model by which we can fulfill the requirements of the various provinces, and they're all very different. So I think one of the questions I would have to this group is the sort of experiences that other MSIs have had in terms of having to bring together the provincial requirements as well as the federal requirements. It's been quite a challenge, and you end up basically going with the most stringent of all, and that is not particularly helpful in some cases, especially in BC, where we're trying to balance the BC requirements, which are a little bit looser at the moment from, say, Ontario. And so I'd be interested to know if others are having this sort of experience on the provincial level.
Is that relevant to you?
Not yet.
Not yet, okay. Good, well maybe we can have this discussion over the workshop. Okay, one more there in the back, or two more in the back? Three more?
Hi, if there is time, I'll speak. Hello, so I'm Natalie Harrower. I'm the Executive Director, quite new, of the Canadian Research Data Centre Network, CRDCN. So it's interesting to hear this discussion because we are all about providing access to data. So to give a slightly different perspective, if researchers want to access data that is part of CRDCN, and this is everyone across the country, they go through an application process that is guided by Statistics Canada, and they have to become what is called deemed employees of Stats Canada in order to access the research. So what we're facing is almost the opposite challenge. How in a global environment, when you want to have researchers connecting on similar topics across social sciences and health, which is our domain, how do you do that if the constraints are around being in Canada and that sort of thing? So we're looking at how do we retain the privacy and the security of the data, because it is personal data about Canadians, while at the same time trying to create those global partnerships. So it depends on the way you look at it.
Thank you. One more?
Last but not least, Fred Worski from the Ocean Tracking Network. We've got a couple of sets of security risks, some associated with our deployments of equipment, because our mandate is to deploy internationally, and the second is in the data. With regards to our equipment, turns out the electronics can be removed and used for improvised explosive devices. So that's something that we have to watch very carefully. In order to avoid a problem associated with that, we work very closely with our manufacturers to make sure about the ITAR listings, what is happening with the equipment, where it's going. In terms of projects and individuals, we screen that through the University Intergovernmental Affairs Office. So when something comes forward that looks like it's going to be problematic, we take a look at that and see, is it really going to be a problem? After discussion, after evaluations, we sit back and say yes or no based on that. And with regards to the data management and data security issues, the best thing we could do is recruit somebody from the Canadian security establishment to sit on our data management team, and that's where we get our advice. Thank you.
Thank you. Did you have another question in the back? No. Yes? One more? Sure.
Yeah, it's maybe not as relevant to the CBG, but to the Amundsen and also the Snow Lab. You know, one of the challenges in bringing new researchers into our facilities is actually just getting them to the facility to see what's possible. And that sort of sits in a white space of, you know, it's not within your operating grant, it's not necessarily within their operating grant, just that sort of exploratory look at what you can offer and what they can do in your facilities. And I wonder about whether other MSIs find the same kind of challenges.
Do you want to respond?
Yeah, it's of course the Amundsen being a remote facility, even a researcher will come in Quebec when the ship is not in science mode, will see the ship, it's good. But the only way I think is really to go and reach out to them directly where they are and explaining what is the facility, what the equipment, what the funding framework and so on. And then suddenly we see the light and they realize that, okay, I can do it. And actually this is only the person-to-person experience that you can do it. And that's why we make so much efforts in trying to visit, you know, our user base as much as we can.
So are there more resources needed that we can tell CFI that we need for that to bring the users to the facility? Is that what you're saying?
Yeah, and there's some facilities that are more easy to access.
Yeah.
CBG, for example, we're from the Experimental Lakes area. It's a hike to get there, right? So, but getting there is the real bottleneck of getting people engaged and being able to conduct research there. And I'm sure, you know, Snow Lab, other MSIs might have similar challenges. But again, you know, how do you meet that challenge when it sits outside of available funding envelopes?
So can you clarify, Mark, is that an eligible expense right now or not?
Outreach activities are, for example, to, you know, Exxon brings example of going out to the communities, presenting what the facility can do. Those can be included within the MSI budget. But as we just said, I guess sort of paying for researchers to come and spend time there typically would be more of a research cost. I guess if it's, you know, in case within the optics of an outreach activity for the days, and that would be something that would be eligible within our budget.
Did you want to add?
So I would echo some of the challenges that Alexandre explained. I think that, you know, we also have the challenge of people not knowing about underground laboratories even existing. And so we do spend a lot of time going out to conferences, going out to individual departments to explain the facility, the services, why they should do their research there. So it's a lot of work to explain that to people, and they still don't really understand till they get there.
I agree that hands-on interaction is really important for being able to communicate how and why this is important. We have training programs that come through the CBG, but you know, we're constrained by staff availability and funding and space to be able to conduct that, but it really is an important part of being able to disseminate this information and get it used worldwide.
Good. Well, thanks very much. That concludes the first session. Unfortunately, our time is up, but I encourage everyone to continue these discussions over the next day and a half and really learn from each other. So with that, we move on to panel 2. Thank you very much, and thank you to the 3 panelists.